Risks faced by Zaporizhzhya. Russia and Ukraine recently accused each other of planning to attack the occupied Zaporizhzhya nuclear power plant in the southern Ukraine. About Zaporizhzhya nuclear power plant. Location on the banks of the Dnieper River, 200 kilometers from the conflicted Donbas region. Significance: one of the 4 operating NPPs in the country since 1984, accounts for 1/5 of Ukraine's annual electricity production. Composition: consists of 6 pressurized water reactor (PWR) units with a gross electrical capacity of 1000 megawatts each. What is a pressurized water reactor? Most common type of nuclear power reactor in the world that uses ordinary water as the moderator and coolant. Composition: pressurized heavy water reactors (PHWRs) are fueled by natural uranium. Light water reactors (LWRs) are fueled by low-enriched uranium. Operating system: a PWR has 2 water systems. Primary reactor system retrieves heat generated in the reactor. Secondary turbine system produces electric power with steam generated by that heat. Reactor design at Zaporizhzhya. Reactors: Zaporizhzhya NPP has 6 VVR 1000 reactors with a capacity of 6 gigawatts total power generation. Primary cooling circuit consists of the reactor vessel with fuel rods submerged in water. Control rods are inserted at the top. A pressurizer holds the water at a constant pressure, around 150 atmospheres, preventing it from boiling. Water acts as both coolant and moderator. Secondary cooling circuit accumulates the heat from boiling, where it converts a separate resource of water into steam which feeds the turbines to generate electricity. Comparison between Zaporizhzhya and Chernobyl. Composition: at Chernobyl, the coolant and the moderator were different, light water and nuclear graphite, respectively, unlike the PWR at Zaporizhzhya where water acts as coolant as well as moderator. Radioactive coolant: the coolant having been exposed to the nuclear fuel became radioactive, flowed out of the reactor vessel while water at Zaporizhzhya never leaves the reactor. Chernobyl disaster: one of the reasons of the Chernobyl disaster was that when the reactor was breached, the superhot graphite caught fire after coming into contact with air. Unlike Chernobyl, the VVR 1000 reactor and its power generation units at Zaporizhzhya are placed inside a large airtight chamber called a containment. Risk at Zaporizhzya. As per the Belona report. Worst case scenario: if the containment is completely damaged, with a projectile striking a reactor while it is generating power could depressurize the primary water circuit as steam and escape into the air, along with radioactive material and other volatile substances. Iodine-131: this mixture will contain the isotope iodine-131 that damages the thyroid gland in humans. Cesium-137: a breach and depressurization would also release cesium-137, which was responsible for Chernobyl disaster as well. Threat would be less as compared to Chernobyl, as the design differences between the 2 NPPs could keep the fallout to within around a few hundred kilometers in Zaporizhzhya. Fukushima scenario: when the NPP is disconnected from the external power grid with nuclear reactions not occurring in reactor, the nuclear fuel has to be cooled, otherwise fuel could become hot enough to melt through the reactor's bottom, contaminating soil, air, and water. Ultimate concern: the working conditions of the 3,000 people at the plant, most of whom have refused to sign new employment contracts with their new Russian employers, due to uncertainties over the management, violation of protocol, and suspicions of disloyalty.
Kindly like, subscribe and share.